Hi, in this video I want to show you how to do what a lot of students find to be one of the more complex types of stoichiometry problems that's changing from grams of one substance into grams of another substance. But before we begin, we need to do some key review to make sure you understand the pieces of this. If you understand the pieces, the rest is going to be easy. So first, there are two useful ratios that we can use in chemistry that we've studied so far. One is how to change from grams to moles, or moles to grams. That's using molar mass. Second is using mole ratios. So I have on the screen here two questions that I want you to try. Pause the video. I'm going to show the answer here in a second. But before I do that, you should pause the video, try to answer each of these questions so that if you're struggling with one topic or the other topic, you need to go back to some previous videos to make sure you know how to do these problems. If you don't know how to do these problems, the rest of this is only going to confuse you. So pause the video, answer the questions. Okay, so the answer to the first question is 0.795 moles of carbon dioxide. That is changing from grams to moles, moles to grams, using molar mass, was from the periodic table. The second question has an answer of 11.2 moles of oxygen. Again, that's just using mole ratio. That's a second ratio you use a balanced chemical equation from. If you are struggling with either one of those topics, please stop the video now and go and review those topics before coming back and finishing this video. Now that you understand, and you know that you understand, the two types of ratios we're going to use, let's look at a sample question. As always, with any problem that we're looking at, you always want to identify what's given to you and what you need to find, or what you want. In this case, the question says, how many grams of ammonia, which is NH3, will be produced by reacting 25 grams of hydrogen gas with excess nitrogen gas? Use the balanced chemical equation that follows to answer the question. So, looking at the question, we can see that what we're looking for and what we need to find is how many grams of ammonia, and what is given to us is 25 grams of hydrogen gas, and of course the balanced chemical reaction itself. So I'm going to just be very formal about this, and I'm going to say that is given to us in addition to the balanced chemical reaction, but I'm going to be a little bit lazy and I'm not going to rewrite that whole thing, is 25 grams of hydrogen gas. Notice when I wrote my units, I wrote not just grams and not just hydrogen, I wrote them together so that you can see them both. Okay. Next, looking at what we're supposed to find, or what we want, is we want so many grams of ammonia. Looking at the chemical reaction, we can see that ammonia is NH3. So, that's my problem. One thing to kind of keep an eye out, and something that does sometimes confuse students, is this phrase with excess nitrogen gas. That is there to make this a good question so that we can run this reaction so we can find an answer. Technically, if I did not have that phrase, if there was no nitrogen available, I could answer 0 and my answer would be correct. Typically, professors will put that in there. Sometimes to try and make the question easy, they'll leave that portion out. But really, questions should include all reactants to show that it's a good question. So moving back to the question itself and solving the question. As with any question, what I'm going to do now is I'm going to start off with what is given to me whenever I'm solving a stoichiometry question. So I'm going to do 25.0 grams of hydrogen. I'm going to multiply that by a ratio. I can see in my ratio, and notice I'm focusing on the units now, that I want to get rid of hydrogen. And looking at the question, it says I want to find ammonia. So, knowing that I can change from hydrogen into ammonia by going to a mole ratio, I find a mole ratio from a balanced chemical reaction. I know that I can say, 2 moles of ammonia is going to be produced for every 3 moles of hydrogen gas. That is a ratio, that is a recipe that allows me to convert from one substance to another substance using mole ratios. So it looks like I can solve this question. I go through and let's start doing the math. I'm going to cross off my units, and as soon as I begin to do that, I see, I have a small problem. My small problem is my units don't match. This problem is set up correctly so far, but because my units don't match, because the grams don't match the moles, I can't do the math on my calculator yet until I make my units match. The hydrogen matches, but the grams and moles don't match. So we have some options here. Traditionally, and what is usually taught, and if you look up a video on other YouTube channels, you will probably see that they are going to ask you to change grams to moles first, which you can certainly do. This I'm going to call option 1, the traditional method. But that is perfectly useful. If I can change 25 grams of hydrogen into however many moles of hydrogen that is, then I can continue from there for my question. That is perfectly fine. The second thing I can do is I can change moles of hydrogen. Let me try to get that into highlighted. I can actually change the units moles of hydrogen into grams of hydrogen. I'm going to call that option 2. Both are perfectly acceptable, but even though option 2 seems to be easier for most students, most textbooks and most chemistry teachers, most videos don't use this option to show how to solve these kind of questions. So I'm going to let you choose your option, and I'm going to go and pause the video here. Choose which option makes most sense to you. Either changing 3 moles into grams, or changing 25 grams of hydrogen into moles. Pick your best option, and I'm going to have another video following this one to help finish solving the question.